So we have some crowns. We took the wrappings off. We have some crowns, and they're going to represent minerals. We've graded up some crowns so that we can use them as sediments in our presentation, in our experiment that we are about to show you. So I'm going to grade up this blue crown, which represents a mineral, because when we have things in geology like erosion and whole rocks become sediments, we get little bitty pieces like this. Now that we have created these sediments, right? So we ground up the crowns and we have different sizes. So we have fine, which is, I mean, y'all can touch this. You want to feel it, how it feels. Very small pieces. That's what we call fine grained. But then when we have objects like this, obviously those are bigger, right? They feel bigger.
Yeah.
So those are bigger clasts or bigger grains. Then put this right here. There you go. Awesome. Awesome, awesome. Maybe use your fingers and get some of the big pieces so that we have those bigger clasts. So what do y'all think about that? Now that we've combined these two minerals, right? We've got bigger clasted red mineral, and then we have these blue little bitty sand pieces on the bottom. So in nature, we get things called depositional environments, which happens at the bottom of the ocean. It's a pretty common depositional environment. So what we're symbolizing here is compaction of sediments. Yep, we're gonna add some fine-grained yellow minerals. Yes. Spoon those out on top of the orange ones, which have the bigger clasts. Awesome, that looks perfect. These are currently pieces of sediment, and in order for sediment to be classified into a sedimentary rock, we have to compact it first. So can both of y'all push on this, push down really hard, try and make that one layer. Don't put pressure points. Yeah, mash it down, firm. Give it an even pressure. Now we have created loosely compacted sedimentary rocks. And we're going to add heat and pressure using an iron, Jeremy.
Yes.
And we're going to show how when you apply heat and pressure to different minerals with different chemical compositions, you get new minerals that grow strictly from the heat and pressure. Doesn't that look way different?
Yeah, it looks way different. It looks like super wet and
super wet
and melted. It looks like it's melted.
Yeah,
It's melted.
It is melted. Don't touch it because it's hot.
That does look like paint.
Yeah?
It looks like if you had, it looks like it just all melted away.
Yeah, you can still
melted
see
into each other.
You can still see the shade.
So when you apply a ton of heat and pressure, so much heat that the rock turns into water, turns into liquid, we call that magma. Liquid rock is magma. And when magma comes to the surface, we call it lava. So now that we're going to open this, we're going to allow that trapped heat to escape.
Whoa.
You see all the liquid?
Yeah.
So think of this as like our volcanic eruption. We're bringing all of this mineral to the surface. And now it's at the surface and it's cooling. Now we have another solid, right? But this is nothing like we started with. That's because this would be considered an igneous rock. What we're going to do, because this is in the core of the earth, there's lots of heat and there's lots of pressure where these are growing. We're going to put so much heat on them that all of our minerals and all of our crown colors are going to mix together. Does that make sense?
Yeah.
Okay, cool. Jeremy, you want to add some heat?
Yes, I do.
So now it's like we're taking two different types of schist with different chemical components because they created new minerals with different chemical compositions. And we're applying so much heat that they're all mixing together, and our beautiful, colorful mineral rainbow is turning brown. This is what happens in the deepest part of the earth, where all of the magma is, and when the magma comes up, like we saw, it cools to make igneous rocks. Yeah, we've got all kinds of colors, right? This is like magma mixing, but it's all happening down there in the earth because there's so many different chemicals.